Super Monkey Ball is one of my favorite game series of all time. Fun challenge, cute characters, and a fantastic community. What's there not to love? And if you've seen any of my other videos, you might also know that I love arcade sticks and weird controllers. So it's pretty perfect that one of my favorite game series of all time started off as an arcade game with a really unique control scheme. The Monkey Ball series got its start in the arcades, with the first game simply titled Monkey Ball releasing in 2001, which was then ported to the GameCube later that same year, with the advertisements for the game showing what else but eating bananas and sucking on balls.
ではバナナを食べると見せかけてボールを食べます。
猿が余る。
あ、そうか。
ボールに入った猿を転がしてバナナを取る。スーパーモンキーボール。
The original was pretty much the same game as Super Monkey Ball, excluding a few graphical and audio differences, no minigames, only one master floor, and the absence of Gon Gon. I guess his inclusion alone warranted the addition of the Super in the title. I mean, I'm not surprised. Oh, and of course, you play using a banana-shaped joystick. And with my love of both Super Monkey Ball and weird arcade controllers, I really want to get my hands on one of these. Let's see how much one costs and... Yeah, that's not gonna happen anytime soon. So I built one myself. And I'll show you how I did it. So this video is going to be two things. A general overview of how to make arcade-style controllers for older consoles, and a look at the Super Monkey Ball banana controller itself. If you're interested in only certain topics, for example, if you don't really care how to build one and you just want to see the final results, use the video chapters down below. And with that being said, ready?
Go!
Let's first talk about how padhacking works. Knowing how the mechanism works can help you troubleshoot any issues if you want to build one yourself. Keep in mind, this is just what I can understand from limited experience. I put a couple of links in the description for better videos if you want a more precise understanding of the science behind this. So on a controller circuit board, there's a thing called a microcontroller chip, which is sort of like the brain of the controller. The chip continuously sends out electrons from a specific pin called the ground pin. The electrons flow through these metal paths called traces, which are sort of like wires embedded into the circuit board, and if these electrical signals reach a signal receiving pin, the controller recognizes that as a button press. However, there are usually gaps in the traces that prevent the electrical signals from flowing, making it so that the controller doesn't register any button presses until you press one down. When you do that, a conductive rubber gasket attached to the bottom of the button bridges the gap between these contact pads. This allows electrical signals to cross over to the other side, where it'll continue down the trace to reach the signal receiving pin and indicate a button press. This is called completing the circuit, which is when you create a closed loop of electric flow. When the button isn't pressed down, you have an open circuit, and the electrical signals cannot flow because of that gap. Since there are multiple buttons, each button has its own signal receiving pin on the microcontroller. And with these, the console can tell which button is being pressed depending on which pin is receiving the electrical signals. If the A pin is receiving signals, that means the A button is being pressed. If the B pin is receiving signals, that means the B button is being pressed, and so on. It can also tell if multiple buttons are pressed if the signals are being received at different pins at the same time. Another important concept is that the microcontroller only needs to know where the signals are being received to tell which button is being pressed. This is important because that means the signals can be sent out from the same trace as long as each button has its own receiving pin. The trace where the electrons are sent out is called the ground trace, and when multiple components share the same ground trace, it's called common ground because they all have a common source and have the same relative voltage. This is good because instead of running a ground wire for each and every button, we can just combine all those ground wires into one long daisy chain to save space and organize a bit better. For electronics, you usually use black wires for ground and colored wires for signal. This is perfect for our project because each of the buttons we'll be using has a different color, so we can just match the color of the wire to the color of the buttons. Analog sticks work a bit differently. You can split up the motion of an analog stick into two directions, vertical and horizontal, and any movement with the stick can be described as a combination of those two directions. The vertical readings are called Y inputs and the horizontal readings are called X inputs. An analog stick uses two potentiometers to measure each direction, and the microcontroller has pins for each of those readings. The first part for the analog stick works in the same way. The microcontroller sends out signals through the ground trace, and once these signals reach the analog stick is when it gets a bit different. Instead of simply bridging a gap in the traces, when you tilt the analog stick, you're basically controlling the resistance of the path that the electrical signals must pass through. Higher resistance results in a lower rate of flow of electrons. Once the signals return to the microcontroller, it can calculate how much the analog stick is tilted based on the rate at which it receives the electrons. This measure of electron flow is called current. So you only need to know how analog sticks and buttons work for the Monkey Ball padhack, but let me tell you how traditional levers work as well. Arcade sticks usually use microswitches with 3 pins. There's a ground pin, normally open pin, and normally closed pin. Of course, the ground pin connects to the ground terminal on a microcontroller, and either the normally open or the normally closed pins connect to the signal terminal, but not both. As their name implies, the pin you connect to the terminal determines whether the circuit will be normally open or normally closed. You should connect your controller to the normally open pin. If you connect it to the normally closed pin, it'll be as if you're pressing that direction on the stick even if you're not. A side note, since we're already talking about it, your buttons use micro switches too, and depending on the brand, you might either get a simple 2-terminal switch or a 3-terminal switch like the ones on the stick. For most cases, you'd want to connect it to the normally open pin, just like with the stick, but there are some cases where you'd want your button to be normally closed. For example, when you play shoot 'em ups, you're holding down fire more often than not, so having the button be set to normally closed would make it so that it automatically fires for you, and only stopping the stream of bullets when you press the button. Anyways, the lever is going to be connected to the D-pad contacts on your controller. There's a switch for each cardinal direction on the lever. When you push the lever in a certain direction, the bottom of the lever pushes on the switch in the opposite direction of where you push the lever. So if you push the lever down, the switch on top is pressed. Basically, you want to solder the top switch to the down trace, the bottom switch to the up trace, left switch to the right trace, and right switch to the left trace. Now that you know the principles, you might be able to piece together why pad hacking works. As long as you replace the buttons and the analog sticks with other components that achieve the same purpose, our controller will be good. So for the buttons, we just need to bridge the gap in the traces and complete the circuit. For the analog sticks, you just need something that'll allow you to vary the amount of current passing through a circuit, such as a rotating or a sliding potentiometer, or a different type of analog stick. Just as a quick summary, if you want to pad hack for yourself, here's how. You first get a controller and take out the PCB. On it are these exposed electrical pads. One of these pads is a ground pad and the other is a signal pad. When these pads are connected, that counts as a button press, and you can wire up each of those pads to a pin on the arcade button. I'd recommend daisy chaining your ground wires. Do that for each of the buttons that's necessary to play the game you're interested in. For Super Monkey Ball, that'd be the start, A, and B buttons. The D-pad works on the same principle, with the press being registered when the ground and signal pads are connected. You can connect the D-pad to the normally open pins of an arcade stick or to individual buttons if you're going for a leverless style controller. Arcade stick switches normally use 3 pins: a ground, a normally open, and normally closed pin. You should connect your pads to the ground and normally open pins. And remember that you should connect the pads to the opposite input of the stick. So the down pad should connect to the top switch and vice versa and so forth. If you want to use analog inputs, get an analog input method like a potentiometer or analog stick and just solder each of the pins in the same order as they are on the controller. So these 3 pins should connect to these 3 traces. And that's pretty much it. Hopefully that kind of helped demystify how this stuff works. Enough of that though, let's get to actually building. So here's basically how the controller is built. The sides are 1x4 appearance boards glued together. Inside, there's another board that's trimmed down and will act like a shelf and hold up the top and bottom cover panels. The top and bottom panels are 1/2-inch MDF sheets, and there's also a sheet of clear plastic to protect the artwork. I drilled holes in the top sheets to fit the buttons and the joystick. I also drilled screw holes for the top and bottom panels and a small hole at the front of the case for the wire to feed through. I routed the edges of the case so it'd be nice and round and then coated it in black sealant. And of course, all the electronic components are put inside after it dries. Tools I used are a miter saw to cut the appearance board, clamps to hold the pieces together while the glue set, table saw to cut the MDF and clear plate, drill press to drill the holes for the sticks and the buttons, power drill to drill the holes for the screws, router table to round the edges of the case and cut the MDF to a certain thickness for the joystick, and a paint roller to apply the sealant. The first thing I did was measure and cut the 1x4 appearance boards. My artwork is 8 inches by 10 inches, so I needed 2 pieces 8 inches long and 2 pieces 11.5 inches long to account for the thickness of the wood. I originally tried to use a handsaw to cut the wood, but my cuts were really wobbly and the pieces wouldn't stick together with glue. If you're skilled, you can probably use a hand planer to flatten the cut, but I just bought an old miter saw and used that. You can also use a circular saw or maybe a jigsaw with the square as a guide. With the boards cut to size, I glued and clamped them together. I try to make sure that the boards are level, but mine ended up a tiny bit lopsided and has a teeter. This won't be a problem though, because we're going to put these non-slip stickers on the bottom later on, which will help even out the surface, so don't worry if yours isn't perfectly level. I also wiped off any excess glue, making sure not to miss any on the inside corners. While the glue is drying, I used the case to trace the base of the top and bottom plates onto the 1/2-inch MDF. I cut them out with a table saw, but a bandsaw, circular saw, or jigsaw would work too. I checked to make sure both cover plates fit in the case and then cut the polycarbonate using the MDF as a size guide. I used polycarbonate for the cover panel instead of acrylic because I find it easier to work with. Acrylic is a lot more brittle than polycarbonate, but there are things you can do to make it easier to work with, like using saw blades with a higher tooth count, or using masking tape to prevent small cracks, or just using a laser cutter. I cut out the button template, which I'll have a link to in the description, and use the scrap paper to play with the stray cat. Crucial step. I taped the polycarbonate and top plate together to prevent them from moving around. Then, I taped the button template on top of the polycarbonate and punched the centers where I was going to drill for the buttons and the joystick. I drilled out the holes with a 30mm bit for the A and B buttons, 15/16 inch bit for the start button, and a 38mm bit for the joystick. I drilled the holes with a drill press, but you can also use a normal power drill. Keep in mind that if your drilling isn't perfectly straight, the holes will be skewed and you might not be able to insert the buttons all the way in. Something else you should know, if you're searching for drill bits, you'll probably come across 3 common types: Forstner bits, hole saws, and spade bits. If you want to use a drill press, you need to avoid using the types of spade bits with the screw heads. If you use these, the teeth are going to grab and start drilling itself into the wood. There are these types of spade bits without the screw tip, but the holes they drill aren't very clean, so it's probably best to avoid using the spade bit at all. So with the outer walls assembled and the top and bottom cover panels cut out, I needed to add a sort of shelf that would hold the cover panels in place. I just used some wood left over from the outer walls and I cut them to be 10 inches long so that they would fit perfectly inside the case. Then, I trimmed enough material off from the top and bottom so that the cover panels and the polycarbonate sheet could sit flush with the walls. Basically, I just cut off twice the thickness of the panels plus the thickness of the polycarbonate. I held the MDF in place to make sure the planks were glued at the correct depths and clamped them down to let them set. I used 1/2 inch MDF for the cover panels because 1/4 inch MDF can flex if you rest your hand on top. The downside is that 1/2 inch MDF is too thick for the joystick to be mounted properly. To fix this, I used a router to cut a recessed area that's thin enough for the joystick to be mounted. I guess an alternate way to do this if you don't have a router is by using 2 sheets of 1/4 inch MDF stacked on top of each other. You can just cut out the joystick groove out of one of the MDF sheets using a jigsaw, coping saw, or whatever else. Then you can glue the 2 sheets on top of one another and drill the button and the joystick holes out after that. I'm just kinda hesitant to recommend this as an alternative method because I've never done it myself, but you know, that's an idea if you want. By the time that was done, the glue for the mounting blocks were dry enough to be drilled. I drilled 1 hole at each corner of the top and bottom panels through the shelves. I also countersunk the drill holes on the bottom panel so that the screws could sit flush. And finally, I drilled a hole at the front of the case for the controller cable. You have 2 choices for the wire hole. If you want the wire to fit through a snug hole, you can use a bit that's slightly bigger than the wire, but you'll have to desolder and resolder the wire back on. If you don't want to bother with that, you can just make this hole bigger so you can feed the plug of the controller cable through. I prefer having a snug fit since that looks better. I actually forgot this step and had to do it later, but I also would have drilled little holes to mount the joystick at this point. I marked on the polycarbonate the drill locations using the joystick mounting ring. For the last part, I used a router table to round the edges, but you can also use sandpaper or a hand file. I tested the router on some scrap wood and made sure the depth is correct. Then, I cleaned off any dust to seal the wood. I used black sealant because that's what the original arcade cabinet looks like. That's it for the enclosure, and for the banana joystick, I just 3D printed mine using this file I found on Arcade Projects from user Nap. I'll put a link to the original forum post, which also has a link to the files. I did have to modify the file since the joystick I'm using has a different base than the original, so I'll also put the modified file in the Dropbox with the button template. The modified part has this bottom shaft cut out, and the hole is a snug fit for the analog joystick. 3D printed parts will have distinct layer lines, but you can get a smoother finish by applying some filler primer and sanding it down. I didn't do that because I was a bit too lazy, but you know, it still looks fine. While that prints, we can work on the electronics. I'd recommend working on the electronics after the case is built. I personally prefer having the case so that I can reference it to check for wire lengths and stuff like that. The parts I used are a GameStop branded GameCube controller PCB, 22 gauge wires, 30mm green and red arcade buttons for the A and B buttons, and 24mm white arcade buttons for the start button, an analog stick, you can find something like this by searching joystick potentiometer, 2 M4 20mm socket cap screws, 2 M4 nuts, 2.8mm wire terminals, and the screws from the controller PCB. The tools I used are a soldering iron, solder wick, flux, tweezers, helping hands, wire strippers and cutters, multimeter, 99% isopropyl alcohol, and cotton swabs. The only inputs you need for this controller are the analog stick, A, B, and start buttons. You do need the other buttons for the minigames, but I don't play those too often to warrant crowding the controller more than it already is. Plus, it's more accurate to the arcade version to exclude those. The first thing I did was clean the PCB. These are usually covered in some extra flux from the factory, but it's old and it's gross, so I soaked the cotton swabs in 99% IPA and just wiped off all the gunk. Next, I desoldered all the unnecessary parts. This included the L and R sliding potentiometers, the analog stick, and the small PCB with the C stick. Desoldering the analog stick can be tricky. Just keep using flux and wick to suck up all the solder and eventually you should be able to pry it off. Don't force it too hard though because there's a chance you can rip off the traces themselves, so just be patient. If you drill the small hole for the controller cable, you also need to desolder it from the PCB. We'll have to feed the cable through the hole later and resolder it back on, so take note the order of the wires. Now the actual soldering part. I used 22 gauge wires to solder to each of the traces on the controller. Remember that each button has to be soldered to two traces, a signal and a ground. We can differentiate between the two if we keep in mind that the ground traces are all linked together. To test which of the traces are linked, we can set the multimeter to the continuity test mode and touch the probe to the different traces. If the multimeter beeps, that means the two pads we're touching are linked, meaning they're both ground. That tells us that the corresponding pads are their respective button's signal pads. Once I figured out which pad is ground and which is signal, I measured roughly how long the wires have to be and made sure there's some slack in them to make it easier when assembling the controller. I heated up the trace with a soldering iron, then melted some solder onto it and some solder onto the wire. Then I used my tweezers to bring the wire and solder to the trace. Once there was enough solder to let the wire adhere to the trace, I removed the soldering iron. I held the wires in place for a bit afterwards to allow the solder to fully cool. This next step is optional, but I soldered a 2.8mm terminal connector to the other end of the wire. This helps me easily connect or disconnect the button in case I ever need to replace it. If you don't want to buy the terminal connectors, you could just solder the wires directly onto the buttons, but make sure you solder them after you put the buttons through the case. One more thing I'd recommend is daisy chaining your ground wires. This is when you get all the ground wires and you combine them into a single long chain rather than having one for every single button. This doesn't save too much time nor space with the monkey ball stick since it only uses 3 buttons, but if you're doing something more complex like a fight stick or a pop-in music controller with 11 buttons, daisy chaining really helps. It's also a lot easier to do this with terminal connectors, which is another reason I'd recommend using them. If you aren't going to daisy chain, the process is pretty much the same as with the signal wires. Just solder one end to the PCB itself and the other end to the button. Since I was daisy chaining, I soldered one end to the PCB, soldered the terminal connector to 2 wires, and a terminal connector to the other end of the second wire. You can increase the chain just by connecting more wires to the ends. The analog stick should be soldered with the pins in the same order and orientation as they already are on the PCB. Once the button wires were done being soldered, I soldered the controller cord back on, feeding it through the hole at the front of the case, and all that's left now is to assemble. I inserted the buttons, connected the wire terminals, and screwed the joystick in place. Then I got the slip-resistant feet pads and stuck them onto the bottom plate. And finally, I screwed the top and bottom cover plates, screwed together the banana halves, and with that, the build is complete. Alright, let's stop monkeying around. Let's go bananas and start ballin'.
Select game. Main game. Normal mode. Advance.
Alright, so this is obviously not my first time using this controller since I've made one in the past, but I do remember thinking that the joystick is a lot looser than what I expected. When the banana isn't attached to it, the joystick is pretty stiff, but I guess adding the banana on top adds too much weight because it becomes kind of floppy. There are some ways I can think of to make the banana stiffer, like switching the stock springs out for stiffer ones or some other methods, but it doesn't bother me enough to warrant doing all that. I'd guess that the original arcade version has the same stiffness of the joystick without the banana. It isn't too bad though. When I play, I usually use 2 hands, one to tilt and one to stabilize, so that actually helps minimize how loose the stick feels.
Ready? Go!
Between using the GameCube stick and this, the GameCube stick is definitely a lot better in my opinion. I don't know if it's just because that's what I'm more used to, but it just feels like I have more precise control over it. Maybe there is a deeper reason, like I'm able to go from one side of the stick to the other a lot faster with the GameCube stick than with this, so maybe that's the reason. I mean, it does make sense this being harder to control with this originally being an arcade game. Gotta drain those quarters somehow, you know? Now, like I said earlier, I haven't played the original arcade version, so I sadly can't give a comparison to how arcade accurate my controller is. I guess I can ask people online to describe how it feels, or maybe even send one of the controllers I made and ask them to compare them. I don't know, it just wouldn't feel right though. I'd still be left with this feeling, this hole in my heart, that my experience as a Monkey Ball fan will never be complete without knowing or experiencing it for myself. And you know, I'll never know if I really did succeed in making an arcade accurate controller. At this point, I knew the only thing I could do was go to the one place where I was certain would have Monkey Ball. MagFest. As soon as I arrived in Maryland, I did this. Then I started planning out my route. I had already confirmed with the arcade donors that they were going to bring Monkey Ball, so it was just a matter of finding it. And so I made my way to the arcade, fully prepared to walk through every aisle to find the Monkey Ball arcade. But to my surprise, as soon as I walked in, I saw it. At first, I was literally in disbelief that I was seeing this machine with my own eyes. After an emotional moment, I collected myself and actually started to try it out.
Trying out the Monkey Ball arcade on the actual banana joystick. Actually, let me compare this. They're pretty similar in size. Yeah, the official one is actually a lot stiffer than mine. Like you can see, this one's like really floppy. But the official one, you just move it and it just goes back right into position. Dude, I think this banana just doesn't tilt all the way because I can't climb up that hill. And it should be super easy. Oh, the gate they use is square in this one. It's not just a circle.
As I kept playing, I realized something I didn't expect. I really liked using this joystick. I thought it would just be a fun novelty, but the stiffness of the banana actually makes it so that every movement you make is deliberate. And paired with amazingly responsive physics, I didn't want to stop. But as MagFest came to a close, I had to say goodbye. And though bittersweet, I left with a big smile and full heart after finally filling that hole in my soul. Finally having experienced the banana myself. So that's it. My understanding of how padhacking works and the steps I took to build my own controllers. Using wood for the housing isn't too common, but that's what they did for the older arcades, so I think it's pretty fitting. And even though this recreation isn't exactly arcade accurate, I don't even care anymore. I got to play the real thing, and I'm happy. If you have even a passing interest in making your own controllers, I really encourage you to try it out. Do it for me. Me. Okay, that's it. Bye.
Monkey wave! Monkey!
Hello. Thank you so much for watching this video. I really hope you enjoyed it. It's been a really long time since my last video, so for that I really apologize. Anyway, thank you for sticking around despite that. It really does mean a lot to me. I know this video was a lot different compared to my other videos, with it being sort of a tutorial type thing instead of a look at an actual controller, but I hope you still enjoyed it, and I hope it maybe encouraged you to look into padhacking or making your own controller or whatever. If you didn't enjoy it, my next video is going to be a look at an actual controller, so hopefully you'll enjoy that. If you do want to get into making your own controllers though, to give you perspective, padhacking was the first project I worked on after I learned how to solder. And then like my first project was like this really shitty GameCube hybrid Smash box controller where it had like analog sticks, and some of the buttons are missing because I recycled them for other projects. But yeah, this was honestly more of a proof of concept. That's why it looks so bad. But yeah, the Super Monkey Ball stick was the project I started on right after I finished this one. So yeah, it's a really good way to practice or like get familiar with soldering. And yeah, I encourage you to try it out if it interests you. And I'll also include the links to the other videos about padhacking that I was talking about earlier in the video. Those are probably going to be better and more in-depth. Again, a link to the files for the artwork and the banana joystick are going to be in the description as well. The banana joystick I got It's a modified file from an arcade forum projects user called Nap. I'm not the most artistically inclined person, so if the artwork file is formatted in like a really shitty way, I apologize for that, but I tried my best. And as you might know, I try to coordinate my outfits to the subjects of the videos, and the hoodie and the shirt that I was wearing on my trip are from Merch Bounce. They're designed by Vivi. She goes by Super Monkey Tweets on Twitter. She's really cool and she's really funny. So if you like Super Monkey Ball content, you should check her out. Not that she or Merch Bounce need my shout out or anything like that. They're way bigger than I am, but I just wanted to express my respect for them because I think they're really cool and I really do enjoy their work. Anyway, yeah, that's pretty much it. Thank you so much for watching this video again. Apologies for the super long delay, and thank you for sticking around, and I hope you'll see me again. Bye.